A single gunshot generates around 165 decibels of acoustic trauma. That is enough physical force to permanently damage and sever the microscopic hair cells in your inner ear. We brought to the gun range a $500 suppressor and right next to it a $1,000 suppressor and everything in between. Today, we're taking all of them to the range to test their sound mitigation, their back pressure, and the extreme thermal accuracy. I also brought an industry expert with us to walk us through the actual fluid dynamics of how these work. And by the end of this video, we're going to find out if spending double the money actually buys you a definitive advantage, or if you're just paying for brand names. Let's get to the range and talk to Ben. Ben, thanks for coming.
Good to see you.
Yeah, absolutely. Thanks for coming out to the range with us.
Yeah.
So can you tell me just a little bit about I guess your experience with suppressors? I know you were telling me you're more of a hunting guy,
Yep.
done more of that stuff. I think most of our audience is like that too. So yeah, what's your experience broadly with like suppressors and cans and stuff?
Yeah, so I mean, I've been with the company for 3 years now. I really didn't have much experience prior to that. Yeah, as I said, I was always just a hunter, duck hunter, deer, stuff like that. So it was kind of new to me when I started, but I was really excited to learn more about it. And since I started the company, it's just been kind of a deep dive into the suppressor world at this point. So I'm trying to learn as much as I can and help other people pick the right stuff for them and stuff like that. So.
Yeah, that's great. That's great. So you told me that you guys do some pretty extensive sound testing.
Yep.
And pretty extensive data capturing on each of these. So you have a bunch of suppressors here, one of which is like $500-ish, all the way up to, I think you were telling me like $900 or $1,000.
Yep.
You know, maybe one of these or something. And so can you walk me through the different sound data on maybe each of these or the different ones that you have here and tell me the differences? Because we can't do crazy sound testing out here, is what you were telling me, because the environment's just so different. But
yeah,
what can you tell me that you guys have?
we take a 5-round grouping and then you get an average based off that. So we'll shoot the firearm, whatever we're hosting it on. In this case, it was a 12.5-inch Mark II. We'll shoot that to get a baseline of unsuppressed noise. And then we'll shoot the 5-round group with the can on and kind of see how that measures. And then you get your reduction value as well as a final just decibel output reading. So there's 2 measurements you can see here. We have dB and then we have dBA. The dB is sometimes called Z as well. We'll look mostly at the A value, so we can see here on this one, the muzzle average is 131 dB, the left ear is 135.5, and the right ear is 135.1. So typically with a silencer, you're aiming to be under 140. That's sort of the OSHA hearing safe threshold. So every can we make is shooting for that, and obviously the more under that you can be, the better it's gonna be for your hearing.
Yeah. Hey, Editor CJ here, and I just needed to point out a couple of things. When Ben mentions OSHA safe hearing standards, we need to talk about what that actually means, because you've most likely never heard of this, at least I didn't before I started making this video. The basic standards here are built around continuous noise. OSHA measures your exposure as an 8-hour time-weighted average, or TWA. The hard legal ceiling for an 8-hour shift is 90 dBA, but a sudden impact noise like a gunshot can never legally exceed 140 decibels under OSHA regulations. Here's how the math works. OSHA uses a 5 decibel exchange rate. That means for every 5 decibels the noise increases above 90 dBA, your allowable exposure time is cut exactly in half. If you hit 115 decibels, like standing next to a sandblaster, for example, you max out your safe exposure in just 15 minutes. Okay, with that in mind, let's jump back into what Ben is saying about how they measure suppressed fire, and we'll be able to understand a bit more of what he's talking about.
And then the other piece of data you get out of this testing is a dosing recommendation. So basically that means this is all kind of developed by the military. We have a whole video on our testing standard as well if people want to learn more about that.
Sure.
But this will give you then a dosing. So this one is set at 467.2 for the muzzle. So that means you can shoot that suppressor from the perspective of the muzzle 467 times in a week without risking hearing damage.
Wow. Okay.
So it's a lot. At the shooter's ear, it's going to be a little different. On this one, it's 82.8 at the left ear and then 66.9 at the right ear. The right ear is always kind of the one that gets you because that's where the port is.
Yeah.
That's kind of the hard one to get down.
So can you walk me through a comparison between like this one and maybe a less expensive one?
Sure. what would that be? This is about a $700 can, I think. That's going to be the Recce 5 AM. So that's, again, another 3D printed model where we print the core and then weld it to a machined rear. So this one came out to 132 at the muzzle, 134 at the left ear, 135 at the right ear. So pretty comparable. It's just a little louder at the muzzle, a little quieter at the left ear, and about the same at the right ear. So that's kind of what I was telling you about earlier. All of our cans are designed to be quiet. That's sort of the intended use case.
It's kind of the whole point, right?
Exactly. So I think, you know, some of the really high flow cans get a rap of being loud and not really doing much for you. That's not the case with a lot of our silencers. Kind of the first and foremost thing we care about is getting the sound down, then getting the flash down, and then doing it all affordably, practically, in something that people want to actually use.
When you're comparing sort of apples to apples here, you're not, the sound is not really the thing you're sacrificing when it comes to the cost.
With us at least.
With you guys in terms of, and maybe this is the case for other brands too, but at least just for us today, the sound is not really what you're sacrificing when it comes to the cost. You're bringing in some other factors, like locking system and some other things that we'll get into.
Kind of the couple things that you can, because I mean, a silencer is supposed to suppress the noise, but that's not the only thing it's got to do, and it's got to do a number of things well. So all of those different features, like an active locking mechanism, that's going to add a little bit of cost. Different materials, like we have some that are just 17-4 stainless steel, like the Sportsman, and then you get into the additive manufactured with the nickel powder alloy, which is a higher cost material, so that's going to add cost, but it's going to be much more durable than stainless steel or some of the other alloys like Inconel.
For sure.
So there's multiple things to think about when you're kind of picking a silencer, and they all kind of factor into the cost.
That makes sense to me. So Ben, let's talk about back pressure. I know this is kind of a big thing in the suppressor world. Not even just suppressors, but just no one likes a bunch of gas blowing in their face, right? Bunch of smoke, toxic fumes, or whatever. So can you tell me the difference with that from, you know, some of the more budget-friendly cans and then some of the higher performance cans? Like I saw, you know, this one, like this has got ridges on it, all kinds of cool stuff. It looks like it's got some cool flow technology going on. So, what can you tell me about the back pressure? And more importantly, why does back pressure matter to us, the shooter?
Yeah, like you said, anytime you're eating a lot of gas, that's just all lead to your face, which is not good, especially if you're shooting a lot. Military people, law enforcement, or people just like to train a lot. If you're less of a tactical, hardcore shooter who's just dumping mags and stuff, back pressure I don't think is that big of a concern. I mean, a normal amount of lead exposure over a lifetime is not going to hurt you. But if you're someone who's really running your guns hard, that's something you want to think about, is keeping your lead level down.
It all depends on how often you're shooting, basically.
Yeah, exactly.
Yeah, if you're shooting all the time, a lot of gas in the face, not great. If you're shooting a little bit, not a huge deal.
Yeah, we kind of have 3 tiers at this point of back pressure. Sort of the lower cost ones are typically going to be more of a conventionally machined silencer. So this is going to be your typical baffle stack. These are kind of inherently going to be a little higher back pressure, no venting in the cap. No flow channels in the ports and stuff like that. But then you kind of step up. So that's sort of a conventional silencer, or a fully sealed, some people call that. So that's stuff like our Recces, our Explorers. They're still going to have reducing features, but it's not going to be a true like high flow.
And that's pretty common, like in a lot of different brands have that, right?
Yeah. Or like hunting cans, you don't, like I said, you don't care about back pressure at that point. So then stepping up from that, we have what we call a managed back pressure unit. This is going to be kind of a cross, more on the low back pressure side than the conventional side, but not like a true open up high flow suppressor. So then we have like the true ultra low back pressure, where this is going to give you the least amount of gas blowback in your face, but also with that is you're going to get a much softer recoil impulse because you're not ejecting a lot of gas back into the system. It's going to be less wear and tear on the firearm, and it's going to be less cleaning and maintenance because anytime you're just trapping all that gas and shoving it back into the system, guns dirty up faster.
I see.
So that's another argument for the low back pressure stuff.
For the shooters, I assume that's kind of everybody who doesn't like gas in their face. What are the mechanical differences going on in a gas mitigating or higher flow sort of can? What are the mechanical differences going on, like internally inside the suppressor?
Sure.
That keep the gas from blowing blowing towards us. I know you kind of touched on it, but what's really going on to help us?
So yeah, this we pulled out. This is going to be a monolithic core, so it's all one piece. If you think about, you know, baffles, you can think each of these little chambers, and if you can see that there's no way for the gas to get between chambers without going through that center bore. So what low back pressure technology does is essentially allowing that gas to route around the bore, around the projectile, and essentially letting it escape out the front without getting captured. Kind of the first thing that people started doing, ourselves included, we had a thing called EcoFlow, where we basically ported the baffles, which allowed a little bit of gas to spill not through the center bore, but from baffle to baffle.
I see.
And like low back pressure technology is just kind of taking that to the max, which kind of came about with additive manufacturing, because you were able to produce really thin walls, little tubes, different channels, really complex geometries to route gas in other ways between baffles, if you can even call them that at this point, because a lot of silencers nowadays with additive manufacturing, it's not even recognizable as a baffle stack. Now you still have to think about cooling that gas for sound reduction. So that was kind of when low back pressure suppressors first became a thing. They were notorious for being just extremely loud and almost not even a silencer, because there was so much gas just getting out of the can that it wasn't even allowing time to work. So that was kind of the game at that point, was how can you make a low back pressure can that's quiet and still has really low flash? Because as soon as you start letting the gas out, that's kind of antithetical to what the silencer's meant to be doing. So that's kind of a difficult challenge, but a lot of companies, ourselves included, are getting to that point now, where you can see we're, with our ultra low back pressure can, we're still under that 140 threshold by quite a good margin. So,
but there's the trade-off between kind of that flash and also the sound mitigation as well. There's kind of that engineering clash that has to happen or the balance.
Yeah, it's sort of a difficult hat trick to pull off of like a low flash, low back pressure, and low sound. It was sort of like a pick two until like sort of the last couple of years when there was some significant advancements made. And stuff, so.
Well, that's exciting. And there's even more people figuring out more cool stuff to do.
Exactly.
Yeah, that's awesome. After talking to Ben about all the gas mitigating features that a lot of these suppressors include or don't include, I wanted to put it to the test. We threw on a very conventionally designed suppressor from Griffin. It doesn't have any kind of front porting or anything that makes the gas sort of flow through the front or anything like that. So Josh, you're going to shoot this one. We lubed this gun up as much as possible.
So I'm going to eat some gas and tell you how crunchy it is?
Exactly.
Okay.
All right, let's give that a try.
You know, you get a little bit of it like right under the nose that you can smell. It's got that sharp odor to it. It's not too bad. It's nothing crazy. I've shot gassier firearms, so there's a lot of other stuff outside of just what the can is doing that determines how much of that gas is going to come back. This charging handle actually seems to be doing quite a bit of work on its own. And of course, it's a Griffin.
Now, the guys are going to swap to the other suppressor, the higher, which suppressor is it, Ben? We're going to throw on the HRT 556. This one is crazy high gas flow designed. So hopefully Josh doesn't get any of that gas coming back at him. But
I've got my targeting reticle on, CJ.
Perfect, just like the guys from Halo. Before we move on to the next part of our testing, let's look at a side-by-side comparison of these cans and see what we can see. On the left side, we have the traditional baffle stack. It taps the sound, but physics says that the pressure has to go somewhere, so it violently forces the toxic gases and unburnt carbon straight back down the barrel, directly into Josh's respiratory system. Sorry, Josh, but we have determined that lead poisoning is not service connected.
Man.
On the right is the HRT 556. Because of that additive manufacturing with vents on the side and front, the complex internal geometries route the gas around the bore and out the front. This leads to significantly less visible gas to the face. If you pair that with a gas-busting charging handle with extra venting towards the right to keep the gas away from the shooter's face on the left, like what we have here, you are going to cut down that gas exposure. This is a huge reason to spend the extra cash on a higher flow suppressor. If you're shooting 500 rounds a weekend, you aren't just buying a quieter gun, which is better for your ears, you are buying lower respiratory lead exposure, which is better for your lungs too, guys. You've said additive manufacturing a bunch of times.
Yeah.
And I'm sure that's really cool for guys like you and me who really care about how things are manufactured and assembled and stuff. But I want to get down to, why does that matter to someone who is looking at cans, who is thinking about buying one? They see that one is way more expensive than the other one, and it has additive manufactured all over the product page or something. And it's like, what does that even matter? Like, to someone like me, it might seem like, well, that's cool for them, but how does that matter to me?
Right.
So can you explain a little bit about how additive manufacturing is starting to really change the game for a lot of suppressor manufacturers, including you guys?
Yep. Yeah, there's kind of, I guess, 3 main points I would bring up for why people should care. A is sort of the material and the properties, like the strength characteristics that you're able to use and achieve are much wider. If you're running parts in a CNC lathe or something like that, the harder the material, the harder it is on tooling, the faster you wear out your bits and stuff like that. So that's kind of a limit to traditional manufacturing, whereas with additive manufacturing, you're essentially laying down a bed of super fine powder. We can talk about the material we use in a second. And then there's lasers that are hyper precise. They scan across the powder, weld 50 microns or whatever the spec is that you're doing. And you do that, I don't know, 2,000 times per layer to build essentially like a skyscraper from the bottom up of just powder being welded to itself. So with a traditionally manufactured can, you typically have your baffles, and then those are stacked up, welded together. So you have sort of these connection points between material, whereas this, you're literally getting solid metal. There's no parts.
It's like, all one thing.
Yeah, I mean, if you cut this in half, there's not even particulates. It just looks like bar stock, basically.
Wow.
Because the powder is so fine and the weld is so good. So that allows you to utilize materials that are much stronger that you wouldn't really want to use in a CNC machine. So our material that we use is actually a proprietary blend that we developed. I actually helped I didn't help develop it, but I made a visual data sheet for it.
Oh, okay.
We call it Nickel 625X. We have a patent pending on it. But essentially it's 68% stronger than Inconel at 1200 degrees Fahrenheit. So if you think about metal, you get it hot, it softens until the point it melts. So this is going to hold its rigidity to a higher temperature at a higher strength level than Inconel or Haynes 282 or titanium or stainless steel. The strength characteristics of this material are super high. It's, as far as we know, the first material ever developed specifically for suppressor use, and we've been really pleased with it. It's lighter than Inconel. It has higher corrosion resistance, so it's not going to wear out.
Well, especially if you're going to go through the hassle of putting these in a trust and doing all this type of stuff. You want to know that it's going to last for.
That's the big thing too, is corrosion. You have a can for 30,000 rounds. You're going to see some corrosion with some of, with stainless steel, just because of the heat and stuff. So this is going to resist that. So the lifespan of the can is way longer. The durability is way higher. You can heat it up, cool it down much faster, much harder, and it's not going to weaken the material.
Okay, there's a lot here when talking about material, so let's break it down simply, because people throw around the words like Inconel or Nickel 625 like it's magic. It's actually just trademarked brand names for a family of nickel super alloys, but let's talk about it. $500 cans are usually manufactured out of traditional 17-4 stainless steel. It's great, but there are thermodynamic limits. When you step up to this $1,000 HRT 556, you're looking at additive manufacturing with proprietary super alloy called Nickel 625X, which is what Ben and I are talking about. Well, why does this matter? Standard 718 Inconel actually starts taking structural damage if you pushed it past 1300 degrees Fahrenheit. Nickel 625X is forged to survive that. It sits at a massive 41 RC hardness, which means it's so strong that manufacturers can engineer internal walls to be significantly thinner. You get a suppressor that is physically lighter on the end of your gun, but infinitely more durable. To put that into perspective, why don't they just make rifle barrels out of this stuff? Because it would be hell on earth to manufacture with current technologies. Standard 17.4 steel cuts in a CNC machine at 700 surface feet per minute. Nickel 625X cuts at a crawling 90. It actively fights the drill. A barrel that takes 10 minutes to cut out of steel would take an eternity out of this super alloy. Oh yeah, and before it can even get to you, it spends about 5 hours baking in a heat-treated forge just to relieve that structural stress of the welding process. But here's the downside. What will eventually limit the lifespan of any suppressor is carbon fouling. As thousands or hundreds of thousands of rounds of carbon permanently bake into the baffles, you lose the internal volume, and when you lose volume, you lose sound mitigation. That is just the reality of physics, guys. There's no beating it. But starting with a material like nickel 625X guarantees the metal itself will never be your point of failure. So let's head back to the range.
But then on top of that, which plays into cost too, is going to be the type of mounting system that you're using, as well as the size of the can. You know, we have these that are 1.73 diameter, so that's just more material, so that's going to raise the cost versus a 1.5 inch diameter. A more complex mounting system like dual lock, there's assembly time that goes into this, Inconel spring, more complex machining. That's going to add some cost versus something like a taper mount or a hub suppressor, which, you know, is the cheapest option. And then sort of what you're getting as far as accessories. So all of our silencers that have a mount welded into them are going to come with a muzzle device right out of the box. So you don't have to worry about buying one of those. Whereas a hub can, we're kind of assuming the reason you're buying the hub can is because you're tied into some other manufacturer's mounting system. So those don't come with a hub mount or a muzzle device, so you'd have to buy that separately if you wanted to. So that's going to lower the cost as well.
I guess I don't know if you know this exactly. We're going to do some testing out here to see what it does, but can you explain how heat affects things like accuracy and velocity, and how I know there's kind of some rumors about that of like, oh, you know, a can will throw off your accuracy, or a can will increase your accuracy, or you'll gain extra, you know, velocity or something. So can you kind of, from what you know, can you kind of go into a little bit of that?
Yeah, I've heard, I'm not totally privy, like the whole velocity thing I've heard about, but from what I understand, it's not any sort of a massive increase. You know, you might get 50 or 100 FPS once the can's really hot. That all has to do with, you know, the interaction of, because I mean, the silencer is almost acting as an extension to your barrel. So the gas is pushing the projectile longer. That's why you can kind of get a little extra feet per second out of there. But once you have the silencer on the firearm, it's going to be pretty consistent from that point. As far as accuracy, I think it's mostly true in a lot of the cases that a silencer will improve your accuracy. But initially, when you mount the silencer on, it's very common to see what we call POI shift. So if you zero your gun without a suppressor on, you put the silencer on, it might shift, you know, an inch down and to the right. But then once it's going to be at that point accurate. It's not like it's throwing it off by an inch in any direction. It's just moving the point of impact. And that's just all based on the characteristics of the silencer. So once you have the can on and re-zero, you're going to have slightly tighter groups with the silencer on than you would without.
Understood. Yeah.
We have the $500 can, we got $900 to $1,000 can, everything in between. Which one do you think is going to have the best group size or hold the tightest groups in terms of accuracy? Because, I mean, shooting is all about, you know, speed and accuracy, and these make things quiet. But, yeah, which one is going to be the best in terms of accuracy, do you think?
That's going to depend, I think, mostly on the style mounting system you're using. If you're using something like a taper mount, that's going to be a very accurate system because, again, we were talking about that forced alignment. So anything dual lock or taper mount is going to be excellent in minimizing POI shift from the get-go. Something like a gate lock or a direct thread, it doesn't have that same sort of forced alignment. So you can expect those to be a little higher. So if you're trying to shoot long range, 500 plus yards, you're going to want to go with a taper mount system or a dual lock system. And then another thing is weight. The heavier the can, the more flex on the barrel you're going to get. It's going to affect the harmonics, stuff like that. So a lighter can is always going to be a little more accurate downrange as well, as opposed to, a 20-ounce can.
Okay.
So okay. That. Yeah.
Perfect. Perfect. Well, let's do some of our own testing and see what it all looks like.
Sounds good.
Yeah.
So what Ben told me was really interesting, but I wanted to put it to the test. So for this test, we are going to be shooting 55 grain X-Tac ammo out of a 12.5-inch barrel, and we're gonna do a speed test. This first one is gonna be a baseline with no suppressor on it at all. We have our chronograph right here set up for us. We're gonna chrono how fast these bullets are going out of the barrel without a suppressor. Then we're gonna throw on the $500 one. After that, we're gonna throw on the much more expensive $1,000 suppressor, and we're gonna see the difference. What are the bullets doing? What are the speeds doing with different types of suppressors on it? Does it make a difference? I don't really know. I don't think Ben even knows either, so let's find out together, guys. Ben, as I'm setting up here, what do you think is gonna happen in terms of speed between, this one and the much more expensive one? What do you think is gonna happen?
I think they're both gonna up it a little bit.
Okay.
If I had to make a prediction, I think the GP5,
okay,
the $500 one, is gonna up it a little more than the very low back pressure HRT5.
Okay.
If I had to guess, I don't know. That's just my thoughts.
Cool.
So
well, let's
see.
find out.
Yeah.
I got a little GoPro recording here. We'll see if we can see anything. All right. Looks like what we got, we did get 10 shots. Looks like what we got is 27.59 on that one. The average was 2738.4. So that's kind of the biggest number that we want to pay attention to. And so we got our standard deviation of 58.6. Our extreme spread is 193.9, almost 200 feet per second for that extreme spread. That's a lot. So I don't know if that's the ammo or the 12.5-inch barrel not getting a great spin on that for this type of ammo. And yeah, so let's go ahead and let the stuff cool down, and then we'll go ahead and move on to the next suppressor. We'll do the $500 one first, see what happens.
So we're at 190.
About 190. So it heated up around 100 degrees.
Yep. It's a little hotter at the end. It's like 300 at the end.
Okay. And that's only 10 shots, so we'll see what happens when we get to our burn down. Let's check it out. So it looks like our average was 27.54, and we can kind of get an idea. Let's look at our standard deviation was 22.3. That's way less than the last one, wasn't it? Yeah. And the extreme spread was 77.1. So yeah, this made it way more consistent shooting than with no muzzle device whatsoever.
Way more
consistent. Which is kind of like the worst case scenario.
Yep.
So even the $500 can, I would consider that like improvement.
Oh, 100%, yeah.
In speed and also consistency.
Yep.
So that's really cool. Well, let's let this cool down. We'll take this one off and put on which one is it?
The HRT5.
HRT5, the $1,000 suppressor. We'll see what happens there.
Yes, sir.
This is our last can, the most expensive one, the $1,000 one. Ben, you want to hit that thing with a heat gun just to see what it's doing before we do the speed test?
So we're looking at 80 at the back.
Perfect.
78 at the front.
Perfect.
78 in the middle.
All right,
so we're
cool.
ambient.
All right, well, let's go ahead and do a quick string of fire, 10 rounds as usual.
Tip, we're at 230. Middle, we're at 300, and the blast chamber is all the way down at 140.
Wow, okay, so that middle, we're at 300.
Yep.
Let's strip away the noise and look at the data for a quick second. Does your $1,000 suppressor make your gun shoot better than a $500 one? Here are the numbers. With no muzzle device, your 12.5-inch barrel was chaotic, giving us an extreme spread of almost 2,000 feet per second. When we add the $500 direct thread can, our standard deviation dropped down from a sloppy 58.6 down to 22.3. Instantly making the gun more consistent. But the $1,000 HRT 556, it pushed the standard deviation down to 13.5 and gave us the fastest average muzzle velocity of the day. The tighter the numbers, the more predictable the bullet, which means we can be more accurate and produce better groups downrange. The takeaway is that the premium mounting system and gas flow actually optimizes the internal ballistics. So if you're a shooter that cares about your group size and you're building a more precision-minded setup, then spending that extra money does indeed pay off. All right, guys, so what we're gonna do here is we're gonna shoot the GP5.
Yep.
Is that right, Ben? All right, perfect. We're gonna shoot the GP5, and this is going to be a group test. So what that means is we're gonna see how hot we can get this thing in about 60 to 80 rounds or so. Then we're gonna see how much our group on our targets open up. So I'm gonna do a string of 10 rounds first at the head of one of our targets, and then I'm going to do a mag dump of about 60 rounds to heat up the suppressor, see how much that group opens up. Then right after that, I'm gonna do a second group of 10 rounds on a fresh target and see how wide our group has opened up. What do you think is gonna happen here, Ben? You think we're gonna see any difference?
I think if there's gonna be a difference, in my opinion, I think it's gonna have most to do with the mounting system.
Okay.
Just because that's a direct thread, I think it's gonna be a little more erratic than the dual lock.
Okay.
But we'll see.
Perfect.
Also the material difference between the two, 17.4 stainless steel versus nickel 625X, that might factor into it. I would assume this one's gonna hold its shape. I don't think either of them are gonna deform.
Right. Okay. Again, guys, we're shooting 55 grain X-Tac ammo. Anybody can get this at any store that you want, local store, shooting goods store, whatever you want. So yeah, let's just get this party started. So first is the string of 10. Cool. I'm gonna start a new session here, and we're gonna load up our first 30 round mag. We're empty. That thing's getting hot.
Yeah.
Woo! Feels great.
Yeah.
Let's try this again. Firing. Clear and safe. Let's do our next string of fire. Okay. Clear.
All right, final temp. 450 in the back, 600 in the middle, and we're back up to 700 at front. So
all right,
probably let it cool a little bit.
Cool. Yeah, we'll let it cool. Let's go up front and check our targets. See what those look like.
All right.
Okay, Ben. So I think
Cold bore.
so. This right here, cold bore 10 round hit. That's this group right here. So dealing with what, probably maybe a 3.5 inch group, something like that.
Yeah.
And then this is our 60 round big group. So this proves not only that I am a very high and to the right shooter, which is something I need to fix, but also I don't think this is our then heated, super hot, what was that, almost 800 degrees.
Yeah.
Right here, that group. I mean, that's about, we have 2 flyers here, 1, 2. That group, that's about a 3-inch group as well.
Yeah.
So,
yeah.
I'm not seeing any huge difference there.
No, I don't. I would say it's negligible.
Yeah.
If anything.
Negligible difference there. So that's good to know. That's good to know that speeds, you know, we gain about 20 FPS or something like that, but then also we don't lose a lot of accuracy because because of the heat.
Yeah.
So that's good to know. Let's try it on the more expensive can and see if there's a gain in accuracy, maybe something else. Let's just do that real fast. And firing.
245.
Okay.
Head of the fins is 615 and 720 out in front.
720 out in front.
It's heating up.
30 more, well then 10 more. Last round of testing here.
We're still under 400, 350 in the back.
Okay.
450 there and 700 up front.
All right. Awesome. Well, let's go check our last group and see if there's a difference.
Film guys.
Am I right? This one might be a little bit more interesting. Because this was my first shot at a cold suppressor.
Yep.
First string of fire. And then this is my next string of fire after that. Now maybe that has to do with Mirage.
Yep.
That does seem to be a bit of a more open group than
Yeah, I
that.
think a little bit.
Yeah. Maybe I'm just that bad of a shooter. I don't know. I mean, I think really the difference is probably negligible, I would say though.
I would agree. You're still completely within this
Yeah.
A zone.
Yeah, within the B zone here, mostly within the A zone. I have like one flyer here.
Right.
And then yeah, the group, this is the total group right here, the 60 round burst opened up quite a bit, I would say, from here versus here versus here. But I mean, at the end of the day, I don't think it's that big of a deal.
No, and I think too, just comparing the two suppressors, I think these groups are tight, especially on this, it's pretty noticeable.
Yeah.
How much tighter that 60 round group is than on the other one.
Yes.
And I think that's probably got a lot to do with the better mounting system of the HRT versus the direct thread option. Could be something else.
That's true, because this group is way tighter.
Way tighter than the other 60 round, yeah.
Okay.
I mean, even these are, I would say, maybe a little tighter than your 10s from before.
Yeah.
Not by much, but.
Yeah, 100%.
Yeah.
All right, well, let's collect all this data and see what we can come up with back in the studio. At the beginning of the day, we looked at these two suppressors and asked, what are we really getting for the $500 price difference? But after pushing them through these tests, tracking the gas and the thermal shift on the chrono, the truth is pretty clear, guys. If you just want to casually shoot paper quietly on a Sunday, the $500 can does the job. But if you want a system that doesn't choke you with gas, doesn't blind you in the dark, and refuses to lose its accuracy when the heat gets extreme, you can't skimp on the cash. You have to buy the tool that matches your specific mission, and as always, it's gonna cost you. But no matter what suppressor you get, you know one thing that makes it look way cooler? Recessing it into a handguard. And there's lots of ways you can do that. There's lots of things that you need to worry about and consider. So if you wanna know how to do it, you can check out this video right over here. I'll see you there. Unlike the hackers on the computers in the TV shows where they're only typing, it's like they're never using a mouse. Okay, here we go. The bro vets will understand. I'm not a bro vet. I didn't get it, guys. That was put there by a bro vet. Okay, anyway. Okay, script. Oh, this is the part that I just have to freaking make up.